Chapter P, Section 5b. You guys watched the video on 5a. It was simplifying rationals. What? Rational is a grown-up word for what? A fraction. That's it. All right. We're going to talk about solving in a little bit. What number is never, ever, ever allowed to be in the denominator of a fraction? 0. So you'll see sometimes they'll have an answer and then it'll say like x cannot be -2. That's called the domain restriction. You guys do not have to do that yet. We'll do that later on. All we're doing this section and tomorrow is working with the expressions. We're not solving. We're not identifying domain or anything like that. So yesterday or whenever you guys watched the video, it was simplifying. Today we're going to multiply and divide. And then Tuesday, Wednesday, we're going to add and subtract. Thursday, we're going to do complex fractions. Then Friday, we're going to start reviewing. The following Monday, we're going to review. And then your test will be on Tuesday. So multiplying and dividing. Everybody knows how to multiply and divide fractions, right? If you have a fraction, say you have 1/3 times 2. No, hold on. Let's say 1/3 times 9/11. There's 2 ways you can multiply fractions. You can multiply across, right? 1 times 9 gives you 9. 3 times 11 gives you 33. And then what do? Simplify, okay? You can do it that way every time. Or we can do what's called cross-canceling, where you cross-cancel inside. I notice that 3 and 9 cross-cancel, don't they? 3 goes into 3 how many times? Once. 3 goes into 9 3 times. Then you're left with 3/11. Everybody with me? Okay, so if you guys have an expression like this, this is what we're going to be talking about today. Can you cancel anything out? No. Some of you are going to go like this. You're going to say that's a 1 and that becomes a 2. Are you allowed to do that? No. I'm going to caution you guys. I'm going to tell you, when you have a binomial, what's a binomial? 2 terms. Put parentheses around it. That is going to remind you that that parenthesis in the numerator has to be exactly the same as the denominator in order for it to cancel. You'll see what I mean in a second. If we're dividing fractions, if I have 2/5 divided by 3/10, do I just go ahead and start canceling all over the place? No. What do you do when you divide fractions? You keep, change, flip. You keep the first fraction the same, change division to multiplication, and then we flip. Everybody remember that? And then we can cross cancel. What happens with 5 and 10? 5 becomes a 1, this becomes a 2, and then we multiply across. 2 times 2 is 4/3. The same concept is what we're doing here. I told you guys factoring is never going away. This is just going to be a bunch of factoring problems all into one. We're going to factor, and then cancel out what we have in common. So watch. I always do the same thing every time because I think if we get some sort of a routine, things tend to run a little smoother. So I'm going to look in the top left. Is there anything I can factor out? Is there GCF, difference of squares, anything in x minus 2? No, so I'm going to put a parenthesis around it. Now I'm going to go to bottom left. Is there anything I can take out of x plus 3? No, put a parenthesis. All right, bottom right, is there anything I can take out of x plus 4? No. And then x squared minus 9. Yes, what can I factor that to? X plus 3 and x minus 3. Good. Now, what you just factored out is gone. Now we've factored all the numerators and the denominators. Any parenthesis that is exactly the same in the numerator can cancel with something that's exactly the same in the denominator. A 1-to-1 ratio. So do you guys see anything in the numerator that's exactly the same as the denominator? And x plus 3. So I'm going to cross off 1 here and 1 here. Is there anything else that's exactly the same? No, so just rewrite what you have. Your numerator would be x minus 2 times x minus 3 over x plus 4. Do not foil that, guys. We're simplifying. We want things to be in their simplest form. So leave it just like that. Questions? We literally are just going to factor, and then cancel out. Again, some of you are going to listen and take my advice. Some of you are not. I understand that. But I'm going to start top left. Is there anything I can break down here? Is there a difference of squares, GCF, anything like that? Yes. What's x squared minus 9 going to become? Perfect. X plus 3, x minus 3. So this is gone. Bottom left, can I factor anything? No, so I'm just going to put a parenthesis. Bottom right, can I factor anything? No, just put a parenthesis. Top right, can I factor anything? No, just going to put a parenthesis. So again, anything in the numerator and the denominator that's exactly the same, you can cross out. What do we see? Okay, there's an x plus 3 in the top with an x plus 3 in the bottom. Good. What else? X minus 3 in the top with an x minus 3 in the bottom. What are we left with? X plus 4. Where is the x plus 4? In the numerator. Do you have to put it over 1? No. But just understand when everything cancels out, there is a 1 remaining. So we don't forget that. All right, scoot along. You guys are doing great. Now this is, again, this is just 4 factoring problems all in one. Don't try to do 32 things at one time. Notice there's a multiplication sign in the middle. So I'm going to first factor my top left. I like to use different colors so I don't get confused, all right? My A term is not 1, so I need factors of negative 12, guys, that multiply to give me negative 12, but add to give me a 1. X minus 3 and x plus 4. Okay, good. Since my A term is not 1, what do I need to do? Divide both of these. So my top left is going to become what? Perfect. 2x minus 3 and what? X plus 2. Great. Now I'm going to go to the bottom left. Yeah.
Don't you take out a 2 first?
No, because the middle term doesn't have a 2. Good thinking. All right, now I'm going to go down here. 1 times negative 5. What are the factors of negative 5 that multiply to give me a negative 5, but add to give me 4? Yep. X plus 5, x minus 1. Great. So I have a multiplication sign. Now I'm going to scoot on over here to the bottom. What can I take out of 4x squared and a 6x? 2x. All right. So when I take out 2x, what am I left with? Look, right here. I'm taking out 2x. What am I left with? 2x minus 3. Good. And now we're going to go to the top right in gray. What can I take out of x cubed minus 3x squared plus 2x? Okay, if I take out the x, then I'm left with x squared minus 3x plus 2. Are there factors of 2 that multiply to give me 2 but add to give me a negative 3? What are they? X minus 1, x minus 2. All right, we just factored, guys. You had those were 4 different kinds of questions on your quiz last week. You just factored a whole bunch. Now that we have factored a whole bunch, anything that is on the top and bottom that is exactly the same, we can cancel. So what do you guys see? An x minus 1 and an x minus 1. Agree. What else? A 2x minus 3 and a 2x minus 3. Okay. Do you see anything else we could possibly cancel? Yes, there's an x on top here and an x on the bottom. Now, whatever you have left over, you rewrite. So I'm left with x plus 2 times x minus 2 over what? 2 times x plus 5. Leave it simplified. Don't multiply it back in together. We're trying to simplify. I see Vincent's iPad, and this is what Vincent has on the number 4. That makes my heart happy. He went through and said, can I factor anything? No, there's nothing you can factor out of any of these. So put parentheses around to remind yourself, hey, x is stuck with negative 1. On the bottom, the x is stuck with minus 2. So guys, is there a parenthesis right now that you see that's exactly the same? X minus 1, x minus 1, all right? Is there anything else we could simplify? Yeah, 5 goes into 5 1 time. 5 goes into 25 5 times. So what am I left with? Yes, there is a 1 over 5 times x minus 2. That is not 5 times x minus 2, guys. It's 1 over. Make sure when everything cancels out of your numerator, you leave a 1 there. Is everybody with me? We okay? All right. Again, this is just a big factoring problem. Factor, 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 factor. Notice this is a multiplication in the middle. So I'm going to start again. I always start in the top left. What are the factors when I multiply 1 times negative 6? What are the factors of negative 6 that multiply to give you a negative 6 but add to give you a negative 1? x minus 3, x plus 2. Do we see the importance of knowing how to factor and to do it quickly? Because factoring is the basis of this problem. Is how you get started, but it's not the whole thing. So bottom left, what are the factors of positive 9 that multiply to give me 9 but add to give me 6? Look at you guys, x plus 3, x plus 3. So now I'm going to go over to the bottom right. X squared minus 4, what does that give me? X plus 2x minus 2. And top right, anything? Nope, it's just going to say x plus 3, and I'm going to put it in parentheses. And now the fun part. Yeah.
I have a question. For top left, could you also put x minus 6, x plus 5?
No, because 6 times 5 is 30. You need the factors of the last. That'll multiply to give you the last, but add to give you the middle. So, take your time. Anything that's exactly the same on top and bottom, tell me. I see an x plus 3 up here, and 1 down here. I see an x plus 2 up here, and I have 1 down here. Anything else? No. Nope. So we rewrite our leftovers. I have x minus 3 in my numerator, and what's in my denominator? X plus 3 and x minus 2. Perfecto. All right, we're kind of cruising along really well, and then we throw a wrench in it. Is this a really big deal that it's different? No. But is it a major deal if you don't remember that it's different? Yes. When you guys are multiplying fractions, we just multiply across. When you're dividing fractions, you have to do what? Keep, change, flip. Do not try to factor first. Rewrite the first, or if you want, change this sign real quick to multiplication, and then rewrite this. Flip it. This becomes x cubed plus 8 over x squared plus 2x plus 4. You have to flip, guys. If you don't flip, your problem will be wrong. You have to flip. If you want to rewrite it completely, that's fine. If you want to change the sign and then just rewrite the second fraction, that's fine as well. But now we're going to do the exact same thing we've been doing. I'm going to start in the top left. Do I have the difference of squares in the top left? No. I have cubes. What times what times what is going to give me x cubed? X. What times what times what is going to give me 8? 2. So what does that pattern look like? Tell me. Perfect. Good job. Now I'm going to go to the bottom left. What does this break down into? X squared minus 4. What does that become? X plus 2, x minus 2. Perfect. Okay. Bottom right. Are there factors, if I multiply 1 times 4, is there factors of 4 that multiply to give me 4, but add to give me 2? No, so just leave it. X squared plus 2x plus 4. The only factors you have are 1 and 4 and 2 and 2. No way you can multiply to get a positive 4, but add to get a positive 2. And now I'm going to go to my top right. Do I have sum of cubes? Yes, I do. What times what gives me x cubed? X. What times what gives me 8? 2. All right, so what does that pattern look like? X plus 2. Is that a good color? It's decent. And then I have x squared minus 2x. Great. All right. Now, guys, all we did was 4 factoring problems from our quiz. That's it. We have not done what the question is asking you to divide these two rationals, not to factor them. But we did the first step. So now we just look and we're careful. Anything that is exactly the same on the top and bottom. I see an x minus 2, good, and an x minus 2. Remember, 1-to-1 ratio, 1 on top, 1 on bottom. What else? I see an x plus 2 on the bottom and on the top, good. Yes, x squared plus 2x plus 4 up here is the same as x squared plus 2x plus 4. So what are you left with? Perfect. Now, always ask, can I simplify that? Are there factors of positive 4 that's going to multiply to give me positive 4, but add to give me a negative 2? No. If you were asked to solve that, like if there was an equal something, you'd have to use the quadratic formula. But we're not there yet, so don't worry about it. You guys are doing great. last page. Again, what's the problem here? It's division. So what do I have to change this sign to in the middle? Multiplication, and I have to flip. Since this is kind of a long problem, are you guys okay with me writing the 2 here and just taking the 2 off of here? Because I'm kind of short on space. So again, let's top left. Sum or difference of cubes? Difference of cubes, right? What times what gives you x cubed? X. What times what gives you 1? 1. So my numerator is going to say what? X minus 1 times x squared plus 1x plus what? 1. Okay, now I'm going to go on the bottom left. What is x squared minus 1 factor to? X plus 1, x minus 1. Okay. I have my lovely multiplication. Are there factors of 1, guys, that are going to multiply to give you 1 and add to give you 1? Bottom right. Are there factors of 1 that'll multiply to give you 1, but also add to give you 1? No, so you just leave it. X squared plus x plus 1. And then, Lucas, what did you say top was going to be?
X plus 1, x plus 1.
Perfect. X plus 1, x plus 1. Factors of 1 that multiply to give you 1, but add to give you 2. Perfect. So now, is there anything on the top and bottom that is exactly the same? All right, an x plus 1 on the top with an x plus 1 on the bottom. Yep. What else? Okay, an x minus 1 on the top with an x minus 1 on the bottom. Good? Yep, that's the same, and that's the same. So, guys, what are you left with? That's it. Do not be alarmed if a lot of stuff cancels out. Do not be alarmed if you're left with just a number. Sometimes that'll happen. All right? What's the problem here? It's division. We got to keep, change, flip. I'll rewrite it. So I have x over x minus 1, in parentheses, times x squared minus 1 over x squared. I know some of you are going to go ahead and factor when you flip it. It's up to you. I'm just telling you, I don't think it's the greatest idea because when we start to do too many steps in one, we get ourselves confused. So top left, can I do anything? No. Bottom left, can I do anything? No. Bottom right, can I do anything? No. What can I do with x squared minus 1 in the top right? X plus 1, x minus 1. Great. So now, do you guys see anything that is exactly the same on the top and bottom? X minus 1 on top and x minus 1 on the bottom. All right, is there anything else that they have in common? An x and an x squared. This x will cancel. We'll just leave one x on the bottom. So what are you left with in the numerator? X plus 1 over x. There you go. Let's do the last one. Then you guys are going to have plenty of time to get your homework done before this class is over. Before you start doing any bit of factoring, what do we need to notice? That there's a division sign in the middle. So we need to keep, change, what? Flip. So x plus 7 is going to come to the numerator, and 3x minus 21 is going in the denominator. Now I'm going to go, again, I do the same thing every time. Top left. Factors of positive 49 that multiply to give you 49, but add to give you a negative 14. X minus 7, x minus 7. Perfect. Okay. Bottom left, x squared minus 49. X plus 7 and x minus 7. Bottom right. What can I take out of 3x minus 21? Take out a 3, and you're left with x minus 7. Great. And is there anything we can take out in the top right? No. So, guys, anything that's exactly the same top and bottom, let's cancel. All right, x plus 7 on the top. X plus 7 on the bottom. Okay. X minus 7 on the top with 1 x minus 7 on the bottom. 1x minus 7 on the top with 1x minus 7 on the bottom. What are you left with, ladies and gents, in the numerator? In the numerator, a 1. And what are you left with in the denominator? A 3. If you tell me that that answer is 3, you are incorrect. The answer is what? 1/3. Okay, one more thing I want to bring to your attention. Again, I've told you guys, if things, God bless you, are written backwards, you should rewrite it. This is why. You're going to see here. If I have something written like this, 2 minus x, is that the same as x minus 2? No. If you have a plus sign, it doesn't matter. If you have anything that's written backwards, I would suggest you rewrite it. How would you rewrite this? Negative x plus 2. And then what was the next step you would do? Negative 1, and this becomes what? X minus 2. Now it's the same as x minus 2. So now you could cross off top and bottom, but what are you left with? A negative. Whenever things are written backwards, I'm telling you, it's going to end up in your answer where you factor out a negative. Don't get stuck with that. All right, you guys, like 5 problems for homework. Go ahead and work on them. Any questions you have, feel free to ask me, ask a neighbor, but good job today.